parent functions and transformations. Now, this was something from algebra, and for us, the patterns of each of these parent functions aren't really as important as the shifts, which I'll explain and talk about. It can't hurt if you remember what the shapes of the graph are, but if you have to, you can just use your graphing calculator. Now, for an absolute value graph, this forms a V where it's up 1 over 1 in each direction. Starting from the origin in a completely unmodified one, just the basic y equals absolute value of x. And the reason, the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2. And then over in the negatives, the absolute value of negative 1 is positive 1, the absolute value of negative 2 is positive 2. Absolute value takes a negative, makes it positive, doesn't do anything to positive. So like I said, it can't hurt to remember the basic shape of that, but you could always just graph this if you have to. Now, for the shifts, inside the bars, and this is true of every function we're going to talk about for this pack, inside is a horizontal shift, and it's backwards from what you normally think. Plus is actually left, minus is right. So inside the bars, horizontal shift, plus is actually left, minus is right. Outside at the end, this is a vertical shift. And this one's easier to picture, kind of. If I just take the V and I add on to all the points, add on to the output, it's going to move it up. If you subtract, it's going to move it down. So this one's normal. Plus is up, minus is down. So what we got so far, inside adding and subtracting number, horizontal shift, plus is left, minus is right. Outside at the end, adding and subtracting, plus is up, minus is down. The other thing you might see is a number out front. Now, we've done this with the vertex form, and you'll see vertex form on these packets here, actually. This is positive. You're upright. And if this is negative, you're upside down. Now, also, if this is greater than 1, let me get rid of that colon there. This is greater than 1, kind of like a slope. So the higher the slope you have, the sharper the V is. It's called the vertical stretch. And it gets narrower. If this is in between 0 and 1, it's a compression. It makes it wider. Vertical stretch, if you got numbers like 2, 4, 6, makes it narrower. The vertical compression, which makes it wider if it's in between 0 and 1. Numbers in between 0 and 1 are fractions, decimals, like a half, 3/4, so on. All right, here we go. X minus 2 on the inside, so we're inside of the bars. Minus 2 is actually right. So there's your vertex. up one, right one in each direction. The whole thing is just shifted 2 to the right. After you get this is actually pretty easy, everyone thought. So here we have a +3 at the end outside of the bars. So like we have there, up. So our vertex, our corner, is up 3. Then you follow the same shape, up 1 over 1 in each direction. Now, I already said this. If you're negative, it just flips it upside down. There's no other numbers. There's no other tricks here. So we're starting dead center in the origin, down 1 instead, over 1 in each direction. It's just upside down. And we already talked about that from vertex form. And then, like I said, this is a vertical stretch. It's like you take the V and you stretch it out. And you can only kind of think of this one as the slope for these absolute value functions out of the ones we do today, because the absolute value has parts that are straight lines. Everything else we'd have to rely on our graph and calculate. So instead of up 1 over 1, it's up 2 over 1, up 2 over 1. Made the whole thing narrower. It's like a sharper V. And then likewise, this was the compression. So instead of up 1 over 1, it's up 1 over 4. Up 1 over 4. Really makes it wider. I count those right? Yeah, I think I did. There we go. Makes it wider. So again, these are just some review here. Minus on the inside, we go back to these rules. Minus on the inside is right. Go right forward, put your dot. There's no other numbers, so it's just a normal right side up V, up 1 over 1. Like I said, these shifts right now are more important than remembering the pattern. Not like this pattern's very hard to remember, but -6 at the end. Oh, down 6. 1, 2, 3, 4, 5, 6. Same shape. Up 1 over 1. There we go. Oh, we have a combination. I mean, it's the same thing though. Left 1, down 2. Left 1, down 2. The whole thing is over. Left 1, down 2. So there's my vertex. Now I'll just draw the V in. Normal V, no different slope or anything. And just for time's sake here, because this is the same thing over and over again, this is what I used to use with my algebra classes when I would teach it. Right 3, down 2 from my vertex, but that flips it upside down. All right, that's enough of those. Now, it's the same idea with the parabolas here. And I mean, this is what we talked about. This right here is vertex form. And this is why on the inside we would change the sign, because the shift is opposite. Plus is left, minus is right. That's still a horizontal shift. This is still a vertical shift. Plus is up, minus is down. That one's normal. And then same idea. And we talked about this. If it's positive, well, if it's positive, upright. If it's negative, upside down. And again, if it's a number greater than 1, it's a stretch. In between 0 and 1, it's a compression. Now, if there's a number here, it throws the pattern completely off. And since this is a parabola, not a straight line, you can't think of it as slope. So in this case, yeah, go for it. Just use your calculator, your graphing calculator, if there's a number here. But anyway, the pattern 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared, 1, 2, 3, 6, 7, 8, 9. The pattern here is over 1, up 1, then up 3 more, then up 5 more. Then the other side is just a mirror image. Over 1, up 1, over 1 more, up 3 from the first point, and then up 5 more and over 1. On the algebra regions, and I'll show you a few of those questions. This was big without a number here. So if you just remembered the pattern, these were quick and easy, and you didn't have to use your calculator. If you didn't remember the pattern, you can just use your calculator. And I'll show you some where you couldn't use your calculator at all, so you had no choice but to memorize these. Anyway, though, I mean, this is the same idea. -3 inside, right 3. So they just shift the whole thing over. So up 1, up 3, and over 1, of course. Then up 5. Then the other side, just a mirror image. Same idea. This is not in the parentheses. There are not even any parentheses there. So there's a 0 horizontal shift. But at the end, +4 moves it up 4. And then up 1, over 1, up 3, over, and no more room. Combination still works. Left 4, down 5, 1, 2, 4, 5. Same idea. Up 1, over 1, up 3, over, up 1, 2, 3, 4, 5, over 1. The other side is a mirror image. Like I said, I'm not doing a super great job graphing here or anything. Just trying to help you understand the shifts are what's more important here. So this is left 1, up 3, but I'm upside down. So down 1, down 3, down 1, 2, 3, 4, 5. And then the other side is a mirror image. And then the square root graphs, same idea. Vertical stretch or compression. If it's negative, it makes it upside down. Inside the radical, horizontal shift, plus is left, minus is right, and then outside, again, this is the same thing. Now, I showed people the pattern. We talked about, hey, squaring and square rooting are inverses. The first thing we did with inverses are swap x and y. So instead of up 1, up 3, up 5, now we're over 1, over 3, over 5. Hey, I counted right. You can just type that into your graphing calculator if you have to, if you needed to know the pattern. Now we don't do the bottom half here. It is a sideways parabola, but we can't do the bottom half because then it would fail the vertical line test. It wouldn't be a function. Anyway, though, same idea. Left 1 to horizontal shift. So over 1, over 3, over 5. Yep. This plus 4 is outside of the radical at the end, so that just moves it up. And then the pattern again. Like I said, the pattern. Over 1, over 3, over 5. It's not as big of a deal if you don't remember that. We're trying to get the transformations down. Negative out front with no other shifts. Over 1, down. Down 1, over 3. Down 1, over 5. Combinations still work. Minus on the inside is right 3. Plus on the outside is up 2. And then just that same pattern. There. Now, like I said, there are some where you can't use a graphing calculator like this. Okay. There's no function. It just says which transformation is 7 left, 3 down. So you got to remember, hey, 7 left, inside is backwards, so it's plus 7. 3 units down, minus. Done. And these are all Algebra 1 questions. We got the minimum point on the graph is -1, -3. It never gives you the function. So we can't use our graphing calculator here. We just got to recognize, hey, this plus 5 isn't inside the parentheses, outside. So it moves the whole thing up 5. So if I move this point up 5, the y coordinate plus 5. -3 plus 5, 2. This one you got to be careful of, though. We're inside the parentheses, so it's right. Now, even though this is minus, we're to the right. So if I move to the right, this is actually going to be plus 4, even though it says minus there. And all we do is change the x-coordinate, since this is only a right shift. Now here, which graph represents G? If G is just -f, and this is F, it got cut off. I don't know what the printer was doing today, but anyway. So it's just upside down. There. This one isn't right because it's been moved up. As you can see, this touches the origin, and that one touches the origin. These are wrong because they've been moved. Oh, and this one's wrong because it's still right side up. Anyway. Now, some of the ones we did yesterday. Given the graph of the line represented by this equation, if b is increased by 4 units, so b is what is added on at the end. If I increase it by 4, it's like plus, so it's up. G here is f plus k, but let's see, G is moved down 1, 2, down 2 at the end, -2. Below we have a graph, ax squared. If a is multiplied by -1/2, so this right here, negative, means if it goes from opening upwards, now it's downward, so it's one of those two. And this was a fraction, so we said that's a compression which would squash the parabola out. So it's wider and downward. Let's see, -2 on the inside is right 2, +3 outside, up 3. The point of yesterday's lesson was to learn these shifts more than kind of the pattern. Because what they can do like this year, and I don't even remember where this was that I found it yesterday, so I'll just write it out. I showed them a couple of hour regencies where it said, below is the graph of y equals cosine of x, which we haven't even done yet, but it looks like this. It's a really crappy drawing. Sorry, it's just a wave. We'll get there eventually. Then it asked, how would it change if I have a minus pi over 3 inside the parentheses? Now, we haven't even done this yet. The shifts still work like what we went over from before, right? Pi over 3. There you go. That's it. There's another one with a logarithm graph, which we haven't gotten to yet. I was going to do it these 2 days along with these shifts, but so many people are out, decided to bail. Even though we haven't done this yet, -2 inside, right 2 units. We don't even have to know anything about any of these graphs. We know the shifts, and then that was the point. So that's what we did yesterday on Monday. Oh, just a quick summary again then. Inside, horizontal, plus is left, minus is right. Outside, which would work for either of these as well, and we'll get to them, plus is up, minus is down. Out front, if you got a negative, it's upside down. Positive, right side up. If you have a whole number, it's a stretch, makes the shape narrower. If it's a fraction or a decimal, squishes it down, makes it wider.